Alzheimer's was, and we all pretty much know as neuroscience majors what it is. It's a neurodegenerative disease that mainly affects the limbic system and cerebrum before it spreads to every other part of the brain. It negatively affects the prefrontal cortex, which has to do with intelligence, critical thinking, personality, behavior, etc. And it also affects the parietal lobe, which we saw in Henry language. So this is a normal brain. Looks pretty good. Has the gray matter and the white matter where it's supposed to be. And right over here is like the limbic system. Let's just keep that in mind. In this picture, which is an Alzheimer's brain. So we can see here the ventricles are enlarged. It's eaten away at the different areas near it, and the hippocampus is pretty much gone. The amygdala is pretty much not even there. And the cerebrum is barely there because, well, the brain's eating away at itself. Okay, so I want to go over some of the causes and risk factors of Alzheimer's. Progressive cell death in the brain can be due to the tau-tangle hypothesis or oxidative stress. And the tau-tangle hypothesis refers to excessive clumps of tau protein, which grows inside dying cells. And the tau-tangle name comes from the shape it makes. It's a twisted shape, and if these tangles keep forming, they cut off the pathway for vesicles, chromosomes, kind of everything you need. And oxidative stress, you usually see this in the aging brain, and there's a lot of molecular steps involved, but the end result is pretty much tissue damage, which we saw in the last picture. So another cause is stress. This can result in depression, generalized anxiety disorder, or severe anxiety disorder. The differences in the general and severe are that generalized anxiety disorder usually is all mental. You usually get anxiety attacks, and severe you get anxiety attacks and panic attacks. Panic attacks are more physical. You can start shaking, all that fun stuff, and you get the mental issues with it. It can also result in bipolar disorder, and stress can also result in alcohol or drug abuse. We see this a lot in PTSD patients. So traumatic brain injury, obviously, cause and the risk of Alzheimer's. Your brain goes through a lot of trauma. And genetics. The risk genes are the APOE4 gene, and this increases the likelihood of developing Alzheimer's, but this does not guarantee that you will develop the disease. Everyone inherits this form of gene from each parent, and it's the leading risk gene, and the other ones are APOE3 and APOE2. And deterministic genes, there are many of these. They come from a lot of different diseases, and if you have one, you definitely will develop the disorder. Has anyone ever seen or read Still Alice? You should read the book because it's amazing. I haven't seen the movie, so I can't make a judgment call, but they talk a lot about the APOE4 gene. There's like a whole chapter where she just discusses it.
We'll have a showing of that movie a little bit later this semester.
Oh, that's going to be fun. I'm excited. Okay, so I'm going to tie in the fear and anxiety pathways because exercise tends to reduce fear and anxiety. So there are two pathways, the long pathway and the short pathway. The long pathway, you are stimulated. It goes through the sensory thalamus to the sensory cortex to the amygdala to get an emotion response. And the short pathway, this one is kind of a scary one because you don't go through the cortex. You don't have time to process it. It doesn't go further than the thalamus and the amygdala. And this is why a lot of people with anxiety disorders have anxiety disorders because they got so caught up in this circuit that their brain is trained to always go through this circuit. It hardly ever takes a long pathway, so they react in a way that can be inappropriate or harmful to the brain. So if we look at this and we see this is the short pathway. It goes up to the thalamus, to the amygdala, and down. So we can see that the hippocampus is right there, and although the hippocampus is part of another fear pathway in the short pathway, it's still near this one, and this is just my speculation, because in the short pathway, the hippocampus is there, it's near everything that's being involved, and so obviously it's going to be affected, and it's going to deteriorate along with the other parts of the limbic system that are affected. So can physical exercise help? Well, exercise increases the amount of blood that is supplied to the brain as well as the number of nerve connections. And when you do physical activity correctly, it has many benefits such as preventing heart disease, weight management, strength enhancement, etc. And many researchers have found that the nerve growth stimulates brain activity. They're kind of the dumbbells of the brain, so exercise raises nerve growth levels, which helps strengthen our neuronal connections. And that's it. That's your little nerve dumbbell guy. So it also reduces stress, which ties into my previous slide. And it also helps cognitive functioning, mainly due to norepinephrine. But there's also the cortisol issue. I just thought I should put this in because cortisol is a hormone that is released in our body when our body undergoes stress. The levels have been found to rise during vigorous exercise, and this makes sense because our bodies go through a lot of physical stress during exercise, and this isn't the correct stress that I was talking about previously, but I just felt like I should put it in because it's still a form of stress. So I found a study, and the objective was to find if cognitive decline in older adults could be reduced by physical activity. They used 170 volunteers aged 50 or older with self-reported memory issues, but no dementia. So this is kind of vague because it's self-reported. It's not officially diagnosed by a physician. And the design they used was a random trial for 24 weeks. The researchers were blind to each group. And if you don't know what a randomized trial is, it means anyone can be put into any group. It didn't matter what their gender was, how old they were. They were just picked out of the hat, thrown into a group. So this was done in Australia, by the way. I thought that was cool. So these are just a few demographics because I think every variable should be accounted for in research. So we can see that ones who completed the trial, 31 of them were women, 11 dropped out. So that would mean that the men, I'm really bad at math, so I have to refer to my notes. 37 men completed the trial in the control group, and the mean age was 68 in all of them. So why do we think, if we look at how many dropped out in both groups, over 50% were women in each group. Why do you think this would be? A lot of women dropped out. I just speculated that it could be health conditions, and dementia usually progresses faster in females. Also, maybe they may be feeling guilt from being away from their family during the study. Okay. So then this is how they assessed it. The Community Health Activities Program for Seniors, or CHAMPS. This promotes physical activity in older seniors. And they asked about current physical activity, how many times a week they exercise, how many times a week they go to church, just volunteer, everything. And they also did a baseline assessment, which Amanda and I are very familiar with. It's not always the easiest, but so during the 7-day, 6-week, 12-month, and 18-month, baseline assessment, participants wore a pedometer, which the researchers had an objective and valid way of measuring the activity. And they also kept a diary. If they participated in a non-walking physical activity such as swimming, biking, this would be accounted for in their diary. And if the participants walked equal to or greater than 70,000 steps a day, then this would be considered active. Anything less than that would be considered non-active.
70,000?
Yeah, 70,000 steps.
Very active.
Yeah. So then the last assessment tool was the ADAS cognitive measurement, which is the Alzheimer's disease assessment scale, the cognitive one, obviously. And it measures 11 items. And some of the items were word recall, word recognition, ability to follow commands, etc. So in the physical activity intervention group, they had to participate in at least 115 minutes of moderate to severe physical activity per week. This had to be done in 3 sessions, 3 50-minute sessions, and if they already participated in over 115 minutes of physical activity per week, they were encouraged, not required, to do another 50-minute physical activity session. So here are the results. The graph shows that, or the table, sorry, the effect of the exercise group and time of cognitive outcomes, mood, and quality of life in everyone. It shows the effect of the exercise group and time of cognitive outcomes, mood, and quality of life in everyone who completed the assessments. And the ADAS cognitive score, the lower the score, the better. And the average for non-Alzheimer's adults is usually 5. That's not shown here, but just to give you clarification. So the between participants columns means 2 different groups were being tested by a different factor. If we look at the factor in the between participants column, we see there is a significant difference between the groups, confirming their hypothesis. Anything less than 0.05 is considered significant difference. So can mental exercise help? Neurons that fire together wire together. We all know this. When you're constantly getting bombarded with new information that you're relatively good at remembering, neuronal changes happen. I'm really bad at pronouncing that word. For example, taxi drivers are constantly learning new routes and going on those routes, so they've been shown to have a larger hippocampus for retaining all the new information. And the more you study, the more your brain is active. So you're learning all of this new and exciting information, like here and now me talking to you. You might know basics on Alzheimer's. So all of those are constantly strengthening or using that dumbbell. And you're also retaining new information about Alzheimer's in exercise. So that's kind of the warm-up exercise for your connections. And studying helps. So not only does it help you get good grades, it's really good for your brain. So what?
I feel like we should thank you for helping prevent Alzheimer's.
You're welcome. So although neurons are not like little muscles, we can think of them like that. The more you exercise them, the more toned they get. So ways to improve physical activity for you: make 12 push-ups your new no push-ups. So you don't do any push-ups, start doing 12. This is what Tina Fey does, so model after her. She's cool. Take the stairs, walk to class, 30 minutes of aerobic exercise per week, 4 days a week is usually good. Stand while you're doing a stationary activity, painting, studying. I do this all the time because, as a lot of you know, I cannot sit still. And ways to improve mental exercise for you: learn new skills every few months. I learned how to knit. I really like knitting now, but I want to learn how to crochet, which is kind of similar, but not exactly, so that's incorporating the new and old exciting information. Challenge your memory. If you look at your phone and you forget what time it is after looking at your phone, try to think, like, okay, I just looked at my phone. Oh, right, it's like 4:34. Okay, cool. Don't be lazy with your memory. Your brain likes a challenge. And relax. Breathing helps. And brain games. I personally use cognitive brain fitness and personal zen. It just gives you a lot of different techniques and some of it personalizes to you. I actually had to get rid of cognitive brain fitness because my free trial ran out and I did not want to spend money. And there are, of course, also a lot of brain games on the internet. And that's my presentation.
Okay, do we have questions? So if we go back to the, you don't have to slide back, just thinking about the study with physical exercise and whatnot, did the authors try and explain why specifically they thought the exercise helped? I mean, they noticed a difference, but did they go into the mechanism?
I looked through and that's not ringing a bell to me.
Mm-hmm.
Yeah.
Can you speculate what you think might have been happening based on the rest of the research you did for the talk?
I mean, definitely neuroanatomic or molecular changes happen when you do exercise, strengthening those connections. So, and it also reduces stress, so I would just speculate that that's why their hypothesis became significant.
Okay. Other questions? All right, thank you, Audrey.